Hello everyone and welcome to this session. I'm sure you all are doing fine. In our last ninth class, the video of the ninth class, I have taken distance time graph, and after that many of you have requested to take speed time and velocity time graph. So that's what I have today for you. So in today's class, I'm going to give you a difference between speed time and velocity time graph. The difference is actually very small, and to understand the difference you need to be a little bit careful while you're dealing with speed time and velocity time graph. And to make you understand that difference, I'm here with this video. Fine. Speed time and velocity time graph. So in the graphs of motion, we know that there are two types of graphs. One is with distance time or displacement time. I think in the last class we have done distance time and displacement time. And here speed time or velocity time graph. So I'm going to give you a simple situation. I'm going to show you a situation and I'm going to show you how that graph will look like and what all can we get from that graph. So without wasting time, let us get into that whiteboard. So yeah, as you can see here in the whiteboard, I'm going to show you a graph where I have speed in the y-axis and distance in the x-axis. Very simple to understand. I have speed in the y-axis, distance in the x-axis. Sorry, speed in the y-axis. You have speed here and time here. Okay, so it's called speed time graph. Now I'm going to take one situation. I'm going to make you understand what happens in that situation and how to draw a graph for that. So look here, I'm starting with zero speed. A car is starting with a zero speed and uniformly accelerating. So you know that in a uniformly accelerating speed time graph, I have a straight line. I will use a straight line here. I have a straight line which comes up like this. This is known as uniformly accelerated motion. So when you take the slope of this line, you are going to get the acceleration value. So slope of a speed time graph gives you acceleration value. Then it is picking up the speed. All right, it starts from 0, it picked up the speed and it stays in constant motion for some time. I would say it has the speed of 50 kmph and it stays in 50 kmph for quite some time. So when I say it is having uniform motion, it is a flat line, a line which is flat. Okay, a line which is flat to the x-axis, and that line represents uniform motion. Okay, so I'm sure you must be knowing the difference, because I'm just going to tell you how to get a velocity time graph from a speed time graph and what all are the implications of it. Then now what happens, it decelerates. That means it is decreasing the speed uniformly and comes to 0 again. So what happens, that graph looks like this. It decelerates and comes back to rest. Now again the speed is 0 here. That means my object is at rest. Now what I'm going to do here, I'm going to extend this line. Okay, I'm going to make this line a little more longer, so because I want to show you more happening here, more of the motion, more of the journey I want to show you here. Okay, so I extend this line a little bit more. Okay, now it stays at rest for some amount of time. That means when it stays at rest, I would say that it is staying in 0 speed for some amount of time. So let's say that it stays at rest till here. Starting from here, it stays in rest till here, right? It stays at rest till there. Now again it picks up speed. Now this time it comes backwards. Remember, the journey starts from A. From B it keeps uniform motion till C. From C it comes to D, which is at rest. From D to E it stays at rest. Now from E onward it is coming in opposite direction. Okay, it's coming in opposite direction with some speed. That means it is going in the opposite direction. You have to remember, now the direction is backwards. So in a speed time graph, you have to show above the positive y only. Here also, now you will show an acceleration. You are going to show one acceleration, and this time it is going to attain more speed. In reverse, it is going to attain more speed. Then it stays at rest for some more time. No, sorry, it stays at the uniform speed. I would say this speed would be somewhere around 80. Okay, now it attains a speed of 80 in reverse and stays there for some amount of time. Then from there 80 it comes to rest again. Okay, so it started its journey in reverse and picked up a speed of 80. From there again it decelerates and comes to zero velocity. Okay, so this is a journey. Okay, I will just name it E, F, G, H. So this is the whole journey. Starting from A till H, you have seen the whole journey of a car. And you have seen the speed time graph for that car. Remember, in a speed time graph, speed cannot be negative. If the car comes backward, or if the car goes forward, or the car goes in the left or right direction, the speed is going to be positive in this case. Speed cannot be negative. Now for the same journey, all right, for the same journey of the car, I'm going to draw a velocity time graph. But here velocity can be negative. And when does the velocity become negative? Velocity becomes negative when the direction becomes opposite. Now let us try to plot that graph. So I will, exactly below this, I'm going to plot a graph, which is VT graph. And this time my VT graph should have a negative axis too. Y-axis, which negative y-axis. Then I have x-axis. X-axis is going to be time. Y-axis is going to be my velocity this time. Velocity time graph. Okay. Now let's begin our journey. Same journey. Accelerates. Okay, accelerates in the forward direction. Same slope, same angle it makes. Stays at rest for some time and comes back to D at rest. Okay, since it's going in forward direction. Remember, my car is going in forward direction, that's why no change. It looks just like the speed time graph. So this is my A, this is my B, this is my C, and this is my D, and this maximum, this value, the uniform speed that it attained is 50. Uniform speed it attained is 50 now. Now it stays at rest till E. So here also velocity is 0, right? When it is at rest till E, the velocity is 0. So yeah, till E, the velocity is 0. It stays at rest. I have it here. Okay, now the car picks up speed in the reverse direction, right? The car picks up speed in reverse direction. It comes in reverse this time, and in reverse it attains a speed of 80 km/h. Now that means it is attaining a negative velocity. Okay, so approximately, yes, here attains a negative velocity and stays in that negative velocity for some time. Then again from there it comes back to 0. Now look here, a small change. Now this is minus 80. You are seeing minus 80 here. You have F, you have G, you have H. Now understand what is the difference here. This is the speed time graph. The first one is the speed time graph of the journey. Second is the velocity time graph of the journey. So the difference between speed time graph and the velocity time graph is when the journey is in reverse, the graph just becomes inverted. Look at this region. Look at this region. This region, all right, this region is a reverse direction region. But in a speed time graph, you just showed it above the positive. That means you showed it above. That means you showed it in positive speed itself. But when it comes to velocity time graph, you cannot show it above. Above means going in the same direction. Your velocity is negative. So that portion is just got inverted downwards. That portion has just got inverted downwards. And this is what the difference is in speed time graph and velocity time graph. Okay, as I told you, the difference is actually very small, not big. A very minor difference that has to come. Okay, so this is the difference in between the speed time graph and velocity time graph. Now, talking about the area under the graph. Okay, let's try to understand what am I going to get in the area under the graph. So, you know very well that when I calculate the area under a speed time graph, so let me show you this also. When you calculate the area under a speed time graph, you are going to get distance traveled. And when you calculate the area under a displacement time, sorry, this is speed time graph. So when you calculate the area under velocity time graph, you are going to get a displacement. Okay, understand that difference very clearly. Area under speed time graph gives you distance. Why? Because speed is distance by time. Speed is distance by time. Area under velocity time graph gives you displacement because velocity is displacement by time. So that is the fundamental connection between them. Okay, so you have to understand this fundamental connection. Now I'll just tell you how it looks like. Imagine the car has went forward to a distance of 100. Let's just imagine that the car has went forward to a distance of 100. So the area under this curve is going to be 100 meter. How much? 100 meter. And the car has traveled backward direction, which is somewhere around 200 meter. So the area under this particular region is 200 meters. So what is this? Forward 100 meter, backward 200 meter. So your total distance is what? Distance is 300 meter. Your distance traveled here is 300 meter. Let's do the same thing here. Now I'll tell you how you get displacement. So here the area under this graph, the areas remain same here. So now the area under this graph is again 100. But the area under this graph is also 200 but in the negative side. So this is 100 meter forward. This is 200 meter backwards. 100 meter forward, 200 meter backward. So total displacement is 100 minus 200, which is going to be minus 100 meter. What does that mean? It means that from the starting point, it is behind 100 meter. The journey has ended from the starting point. This is the starting point, students. If the journey is ending behind 100 meter, that's going to be negative 100. If the journey is ending forward 100 meter, it's going to be plus 100. So displacement is also negative. Displacement can also be negative and positive. Negative means in the backward, positive means the forward. But displacement is distance is always positive. So your displacement is minus 100. That means it goes 100 forward, minus 200 backward. So your final displacement is minus 100 meter. That means it is sitting back 100 meter. It is sitting or it is finishing its journey in the reverse direction in 100 meter. Right? So this is the significance of a speed time graph and a distance time graph. Sorry, velocity time graph and a speed time graph. And one thing is common for them is that the slope under the curve, the slope under both the curve, the slope value under both the curve will give you acceleration. Okay, it doesn't matter which graph it is. That is the common thing in them. If you take a slope of speed time graph, it will give you acceleration. If you take a slope under a velocity time graph, that is also giving acceleration. So that thing is something which is going to remain constant here. But the area under a speed time graph is giving a distance. The area under a velocity time graph is giving you displacement, and this thing has to be registered in your mind, and this difference you need to understand very clearly. So I hope I have made a proper sense to this particular concept. So yes, students, very well. I expect you all to participate in the poll which is in the description. I want you all to tell me what should be the next topic should be, right? So your suggestions will help me to make the next video. So I really want you all to just go to the description and take part in the poll and let me know what topic for 9th grade can I make the video next. So right now I hope I have made you this small concept clear to you. So with this I will end my today's video. I want you all to, as I told you, to participate in the description poll, and if you have any doubts regarding your subject, I want you all to put it in the poll. So students, I will end my video now. We will see in the next session. So until that, adios.